And we are live now. So, hey friends, this is me, Vishwas Nayan. I'm the host of this podcast. A lot of times, IAC has always been the mysterious puzzle in the DevOps world, right? So, there is always a chance that, you know, IAC adoption has always built that new standard for DevOps today, whether it's from ease of use, the practice of it, or else anything that combines with respect to where we have to take this technology. And I think this is absolutely a pleasure to know that WingCloud is not just an additional IAC tool that is there in the market, but it's actually changing the way you even think infrastructure as code, and even provisioning has become much easier and faster for us. And who better than Shy to just give you that persona of like not just an IAC which is changing the world today, but we'll talk it in terms of an IDP implementation, or else an approach in which you can take one development phase into another. So thank you so much, Shy, for being on the show. Means a lot.
Hi, thanks for having me, Vishwas.
Cool. Let's start with this question about like what was your journey as an engineer? Like, let's get to know that, and we'll just go on with it.
All right. So I started my engineering journey actually as a 13-year-old child who learned C++ from a book my father bought me, and I liked being able to tell a computer what to do basically and to create. I don't I'm not a good painter. I'm not a good. I can't play any music instrument, but writing code is my way to create things and bring them to the world. Um, and so I started as a just as a kid writing software for fun. Then I studied computer science, and I started my professional career in Microsoft, where I was a software engineer with a it was an amazing school to learn engineering practices, working with very talented um, uh, engineers in a big company who knows how to deliver code. And after 5 years there, doing different roles, a lot of them in what today might be called platform engineering, um, I, uh, I left to start an entrepreneurial life, and had a startup with friends, and we sold it to Verizon in the US after 3 years. Then then I was an investor for a few years, and then got back to the game. Things have really changed by then. When I left Microsoft, when I did my startup, um, it was the old kind of the old world. Cloud had just started, but people still didn't really lean on the cloud. They just looked at the cloud as these machines that are just someone else's machines and not sitting in your um, in your data center, but they didn't really use all these different cloud services. But when I came back to the game, it was 6 years ago. The cloud was much more mature, and we had these new paradigms like serverless and Kubernetes, and so it was lots of fun to build software again with much newer tools. And then 2 years ago, I linked up again with a friend from Microsoft, Elad Ben Israel, who's actually been developing infrastructure as code tools in Amazon. He's built the AWS CDK for those who know what it is, and he's also worked on CDK for Terraform and other projects. And he left Amazon to kind of take it to the next level, and he showed me his vision of where he wants this cloud development to go, and I was instantly hooked, and I joined him, and we've been building Wing according to his vision ever since in the past two years.
Great. I think there has been a huge, humongous shift, right? Let's just talk about it. Let's talk about your journey of building something from zero to one. I think to audience who doesn't know, WingCloud is unique in terms of its proposition, in terms of whatever the IAC tool is, but it has an open source edge to it as well. So I just wanted to know your perspective about your entrepreneurial journey, and like, let's talk about your first 0 to 1 journey that really made that impact, because Wing Cloud also is helping many organization in that 0 to 1 journey. So let's talk about it.
Yeah, so I think it's kind of weird, but when I was a kid, the world was easier in a lot of senses. It was much simpler. You would just write code in your IDE, you would compile it locally in milliseconds, and you would be able to play with it. And then you would create an installation package that you would then distribute, and your users would install. Um, and so everything kind of made sense. And um, as companies started to create more complex software, putting it on data centers and later on the cloud, something I feel kind of got lost on the way. Like this very short and simple cycle where you as a developer can control your entire software lifecycle, can just work locally, and test everything locally with ease, kind of got lost. At first, it was like, all right, I'm a developer at a company, I create the software, and then I give it to the IT department, and they then take care of deploying it and for all the operation and make it scalable and available. Um, but that was still okay because I could develop it on my machine and then hand it over to them. But then, as the cloud became more and more complex, you kind of needed to become cloud expert yourself as a developer, to really intimately know every layer of the cloud stack, to understand about networking and about security. Um, and as you compose your app from different cloud resources, you find yourself unable to actually write software locally on your machine and just test it. You need to deploy it to the cloud in order to test it, or to use some tools to emulate parts of the cloud. So I think today, in an ironic twist, the journey of 0 to 1, if I'm just a developer who wants to bring something to market, um, it's much harder than it was in the past. And one of the things that we want to do with Wing is to make it easy again for developers to do that.
Got it. I think this is a persona that has been evolved over a course of time, right? You know, when I think of putting anything into an Terraform or else anything that is there today, my first question is like, are we doing it right? And any IAC tool, right? It can be of anywhere, but my first question is like, are we doing it right? Because my architecture's diagram says everything that has to be there, but should I even think about what is the networking aspect, what is all these covering into, right? So let's talk about the IAC as a vision, or also IAC as a definition of an practice. So I think you guys have been developing an tool which is for this ecosystem. So let's talk about it and figure out what is the actual definition of it, and are we doing it right?
Sure. So I think in like infrastructure as code makes a lot of sense. Basically, in today's cloud, you need to kind of set up everything, set up your infrastructure, and there are ways to do it like without code. But then, as the infrastructure gets more complex, these like YAML files and whatever, they become also too complex, and then you want to start doing composition and inheritance and all these things. And so that's basically how Elad started the CDK. He said, why can't we just use code for that? Code is a tool that was perfectly developed and honed over a lot of years in order to to express to build complex systems. And so I think being able to use code in order to define an application's infrastructure makes a lot of sense. And for that, I think infrastructure it's something that infrastructure as code does right. I think what's not right in today's world with infrastructure as code is that um, developers are either expected to also learn how to work with it, or they need to have a lot of friction with DevOps. So DevOps do it for them. I think the boundary between application and infrastructure is kind of wrong. We're at a place in the cloud today, kind of where we were with traditional computers, maybe 20, 30 years ago, where if you wanted to create a software, you needed to write machine code, very low level machine code, teach um, you had to write code for specific processor, specific operating system. But then, as the ecosystem evolved, we advanced in the abstraction level, right? So you no longer had to write low-level code. Today, in traditional computers, you can write high-level code. You say you want to use the file system, so you just declare that you would like to create a folder or a file. Doesn't matter which file system on which operating system you use, and you have programming languages and frameworks that enable you to then deploy it to Mac, to a PC with different processors, to your phone, on the web, wherever, and it just runs. And I think this is where we also need to go with the cloud. I think developers shouldn't have to target specific clouds and specific services and wire them manually, generating IAM policies and network topologies. They should just say, yeah, I want to put an object in the cloud somewhere, like I want to put a file in my operating system, in my computer somewhere. And our tools should be good enough to abstract the details. Um, and yeah, I think you still need to have these platform guys or DevOps guys that can um, tweak everything below that abstraction level, but they should be able to do that completely separate from the developer. The developer shouldn't have to come to them and say, I need a bucket or I need a queue or anything like that. Developers should just say, can add a queue or add a bucket to their app, and then the platform guys should be able to define how a queue or a bucket behave um, in the application. So that's, I think, where we're going. There are different projects that are headed this way, and Wing is one of them.
Cool. Got it. Platform has multiple services today, but I think the biggest trend that is coming out today is like Terraform adoption, or else Kubernetes adoption. It's open source, but there are so many things that goes wrong, and even the Kubernetes aspect, right? There are so many drivers that you need to just get through. There are so many CNI connections that you have to get through. Drivers only. At the end of the day, it's basically the drivers, the packages that goes behind. So how can a tool like Wing Cloud make that differentiation when we are talking about upgradation of a software? Of course, there are multiple tools, multiple technologies, and multiple different versions of the same cloud services that are coming in, but how can a tool like Wing Cloud make that difference?
So basically, we're just an abstraction layer. I see it as an abstraction layer above those tools. So the same when you write C sharp or Java or whatever higher language code. Eventually, it gets compiled to assembly, to machine instructions. I see the same thing with Wing. So we allow developers to write higher level, to operate at a higher level of abstraction, and and treat the cloud as this abstract computer. So you don't target a specific cloud; you just target this abstract notion of a cloud and all the services that it is composed of. And then we compile your code to Terraform, to Kubernetes, to Pulumi, to whatever lower level instruction set you want to target. And the platform team or DevOps team, they can operate at that lower level. They can go ahead and customize, um, and they can create um, different it- think of it like a Terraform module. They can create different APIs or different libraries that the developers uh, can then uh, can then use. So a DevOps engineer can maybe compose um, like a smart bucket that has all the redundancy policies and all the encryption policies, and it can maybe have backup that it puts it in different buckets in different places. It's a complex system for the developer. It doesn't matter. He just wants to put something in a bucket. So um, the DevOps or platform engineer can create this complex bucket. They can use Terraform, they can use whatever, but then in the end, the developer just has a bucket that they can uh, use in Wing very easily. Um, and another I think important aspect of being able to work at a higher level of abstraction is that you can then also work locally, because you can compile to Terraform and Helm and Kubernetes and other lower level cloud instruction code, but you can also compile to a local simulator that just gives you the functional contract. So as a developer, if just want to test if my application works locally and play with it, I don't really care about encryption. I don't care about redundancy. I don't care about any of that. I just want to see that I put the right object, and that I read the object at the right time, and that I do the right things with it. And so when I allow developers to work at a higher level of abstraction, they can then also target the local simulator and work very, very fast and iterate on their code.
Sure. That's great. That's great. And yes, of course, there are so many things that goes behind when you're doing an massive implementation, right? So scalable implementations are not just like you set rules, you set technology, but you also set a set of visibility. I think that is where local emulators, the visualization layers, all these things comes into the picture. So let's talk about IDP implementation, internal developer platform implementation, because this podcast is mostly tuned around in that way, but we are trying to push ourselves more in this comfort zone of okay, let's make the visibility much easier and faster. Let's relook at where we want to take the infrastructure to the scale that we are trying to target. So let's talk about, can IDP implementation change the way we are going to think technology or else any implementation right now?
Yeah, I think IDP is definitely a step in the right direction. I think anything that allows developers to basically the premise behind IDP is that you want a portal for the developers can use and use the cloud in a self-service manner with less friction with platform or DevOps teams, and you get visibility into um, what your application is composed of, and so I think it's definitely a step in the right direction, but it's not the whole story, because at the end of the day, developers need to write code. So IDP gives them the layer maybe to get started, right? They can easily create a new microservice, or they can easily request cloud resources that they need in their application, and they can do it in a non-code way or low code way, which is great. But then once they leave this scaffold, they need to write code, and that's I think still the missing piece. We also need to make sure that the code they write is is at the right level of abstraction, uh, so that they can focus on their business logic needs and not on lower level mechanics.
Cool. That makes more sense. That makes a more impactful sense because uh, I've seen different levels of abstraction that goes in when we are trying to say we are in the comfort zone of creating a new set of challenges for my developers. So I have always been in that position where it's been like a new set of challenges created just for me to make sure that I learn something about this infrastructure. So I think that visualization layer is one thing. There is an abstraction layer that you need to understand. Okay, where is the flaw? By not just the visualization but also the templatization and a lot of other stuff that is happening in the IAC space or else even in the IDP space. I think that makes more sense today
Yeah.
to actually think about like, hey man, this is where we want to take it. And I think this is a cool set of an insight. This is a good amount of insight for anybody who is starting their journey in IDP and making sure that they learn something from this IDP implementation. I think yes, this is a coolest way of saying this is where we want to take it. And thank you so much, Shai, for sharing such kind of an insight. This insight is not just about what technology has to be defined. It is an actual implementation that you need to go through. So yes, thank you so much.
um, Always happy to talk about these subjects.
Sure.
uh, And by the way, you touched just a small thing addition. You touched templatization, which is something that yeah, I think a lot of IDPs are going down that route. I think this is something that can be better. I think templates are not the ideal solution to the problem that they're trying to solve. Yeah, a template um, gets you started very fast,
Mm,
but it doesn't. But software is a living organism that evolves all the time, and
mm,
so if you start quickly with a template, that's great. But then let's say that you have a new version of the template, but you now have older software that has already started with the older version of the template. Now you need to make sure that everyone updates their code, and this is why I think the better way to go is to use library wherever you can. Use a library instead of a template, because a library is something that you can then update. If I'm a platform team and I create a template, I now need to chase my developers whenever I change something in the template, make sure that they update it and make modifications. But if I give them a library that they can consume, then I can just update the library, and they automatically get updated, and I also have visibility. I know which team uses which version of the library, and it's easy to follow and understand um, where things stand in the organization.
got it, got it. I think this is cool. Thank you so much, Shai, for this amazing insights. It means a lot. Thank you so much for it.
Thank you. Happy to talk.
Sure. Let's just end the broadcast, folks. So this is me, Vishwas Naran, signing off from the show. See you soon with a new guest, a new perspective.